be like, here's an email with your stuff. Take this. Like, okay.
I've been getting so many emails like, can we do counseling over email? I'm like, no, like I want to talk to you.
And to be fair, I wanted to talk to them, but they always just sent me an email of the classes I should take.
I
was
see.
like, okay,
If we could do it by email, I would just write a bot to do it for me. But
Chat GPT.
yeah,
Tell this guy what he should do.
the problem with that is that I can write the bot, but then when the bot gets it wrong, then it's my fault. So
Don't write it wrong.
I
Simple solution.
don't know if AI, I don't know if AI is that good yet.
Well, here's what you do, right? You offload the task to like a junior or something,
Uh-huh.
and then if it gets it wrong, then you can just blame them. I'd be like, oh, it wasn't me, it was this guy.
The old management special.
Yeah, the old, not my problem. Pull a fast one on.
Barry yesterday, right?
Yeah.
Who did you talk to?
I talked to Whiting, Turner, Encore, Irvine Ranch Water District, some electrical engineering company. And then somebody else, I don't remember.
All right.
And then it just got too crowded in there. I was just like, screw this, man. I'll go do something better with my time and stand in line and give somebody a resume that I'm not gonna look at.
Yeah. Are you interested in license to sign?
I'm interested in your job, so
Yeah.
we'll see where that gets produced.
It's kind of, let's see if I can. I think I turned it down, but it almost feels like the air is not even going, so. All right, it's 1 o'clock. Let's go and get started. All right, good afternoon, everyone. How's everyone doing? Doing good? Everyone have a good ECS week? I think today's wrapping up most of the festivities, so you might get a guest professor in one of your lectures later today. But not this one, because this guy was too slow in answering the email for that, so it's me. But hopefully you guys get a chance to speak with one of our industry partners at one of your other lectures for today. Okay. All right, so the plan for today is we're going to finish up our lecture notes on rate of return analysis. And so I have a few more examples that I want to do, a couple more concepts, but it's just kind of more practice doing rate of return analysis. Okay. All right, and so so that's the plan for today. Couple announcements. And so homework 2 was due last night. And then homework 3 should be posted already as well. I'm pretty sure I activated it already, but if it's not activated, I'll go do it when I get back to my office. But that's going to be due next Friday, right? So you have a little bit over a week to do it. Not too long, just because our midterm exam is going to be the following Tuesday. So not next Tuesday, but the Tuesday after that. And so next week on Tuesday, we're going to talk about the midterm a bit more, talk about the format of the midterm. I have a study guide for you guys to help you guys study. And then we'll take the midterm on the Tuesday after that. All right. I think that's about it. Are there any questions I can answer before we get started for today? Okay. All right. So let's go ahead and pick up where we left off. And so we were going over rate of return analysis. So just a little bit of a refresher, rate of return analysis. Basically with these problems, we are doing a little bit of a different approach compared to our normal economic analysis problems. In rate of return analysis, instead of having the interest rate given to you, it's going to be your job to find out what the interest rate is. And so on Tuesday, we introduced this concept. We did a couple of examples to kind of show you how this works. Remember, there are two kind of main ways to solve it. You can either solve it using the formulas. And because the formulas end up being quite complicated, especially with some very high powered exponents, the best way to actually solve it with the formulas is to plot. And so you can plot in MATLAB, you can plot in your graphing calculator or Excel, Google Sheets, whatever is most comfortable to you. Okay. So that's one option. And if you're kind of savvy with that, you can go that route. The other method that we learned to solve these problems is through using the compound interest tables. Okay. And most of the time, if you go this route using the compound interest tables, you're going to have to interpolate the result. Right. Remember, the compound interest tables, they give you all the conversion factors that you need, but they only do it for set intervals of the interest rates, right? So they only do it for like 4%, 5%, 6%. And oftentimes when you do these problems, the rate of return is usually somewhere in between those. And so in order to get the true rate of return, you have to interpolate between different values on the compound interest tables. And so I think the last example that we did on Tuesday covered that, okay? And so, for the homework assignment, this stuff isn't on homework 3. Remember, there's rate of return stuff. I'm not going to test you on it until the second midterm. But for the homework assignments, it doesn't really matter to me which method that you use. But for the exam, because the exam is going to be closed, closed computer, I would at least familiarize yourself with the compound interest table. Okay. All right. So on Tuesday, we introduced kind of this concept of rate of return. So today, I just wanted to mostly just do more examples and to kind of show you some applications. Okay, so let's start with an example. Okay. So a common situation that comes up a lot when you're kind of in charge of managing an engineering project is kind of what you're going to do with your big pieces of equipment, right? A lot of times you're going to need to use either a big manufacturing machine or maybe a big pump or maybe a big construction machine to get your project done. Okay, and this machine may not be something that your company already has on hand. And so in order to complete your project, you need to obtain this machine in some way, right? And oftentimes you have the option of either purchasing a machine. So that's kind of very similar to kind of what we assume for a lot of our problems so far. Or another option is to lease it or to rent the machine. Because sometimes, the machine that you may need may be something that's highly specialized, and it may not be something that your company is willing to hold or to even to sell afterwards as well. So leasing is always an option as well. Okay. And of course, the financials for each of these are very different. And so you can use rate of return analysis to determine which is a better option. Okay, so let's do the example. Okay, so we're comparing two options here. Okay. So option A is to lease. Actually, I don't need to label this A and B, it's just lease or buy. Okay, so under the leasing option, the cost to lease the piece of this piece of equipment is going to be $2,500 a month. Okay. It's basically just a straight up rental fee, so you just pay it at the end of the month. Okay. Or you can buy it. Okay? And so purchasing this piece of equipment is going to cost $40,000 upfront. But if you buy it, you can salvage it as well because you own it, right? And so the salvage value in this case is going to be $6,000. All right, in either case, this piece of machinery is planned to be used for 2 years. And since the leasing cost here is per month, so we're going to do this analysis per month as well. Okay. So 2 years is equal to 24 months. All right, question: are we skipping the example for investing 100 versus 200? We're going to do that one after this one. Yeah. Yeah, I kind of skipped ahead in my notes a little bit, but I want to do this one first, and then we'll do the 100 versus 200 in the next one. Yeah. Yeah, I was going. We kind of reached the end of class last time, and I was kind of just going based off memory because I didn't have the rest of my notes, so I kind of skipped ahead a little bit too much. But that example is coming up. Yeah. Okay. All right, and so in this situation, we want to find out what is the better option for us financially. All right, let me rephrase that a little bit. And so if we were to purchase it, what would be the rate of return on that action? Okay. This actually feeds into the $100 versus $200 one because we're gonna solve this one in the same way. Okay. So let's go ahead and make a table comparing these two options. So let's list out the costs for each one. Okay, and so we'll list the cost out for each option per per month. Okay. Okay. So for the leasing option, the cost here is $2,500 per month, and so we are going to pay that actually up front in this case. And so the policy that this leasing company has that you pay the money up front and then you use it for the month. Okay, that means we're going to have a cost of $2,500 each month. Okay. But then in the final month, or at the end of the 24th month, we don't have to pay it because we kind of paid it forward. And so a little bit different than how we normally do maintenance costs. Usually maintenance costs we put at the end. For leasing costs, usually you pay it up front. Because no company is going to lend you their equipment without you paying anything. Okay, and so for the buying option, we have our initial cost of $40,000. We're going to assume that we don't have any maintenance costs. Okay, so we basically pay for everything up front. And of course, when we're done with the piece of equipment, we can sell it for $6,000. Okay. All right. And so the argument that this problem is making is that if we were to buy this, buying would be a more economically feasible option. And so if we were to purchase this, over the course of the 24 months, what would be our rate of return for that choice? Okay. And so in other words, we want to compute the interest rate for this buying option versus the leasing. Okay, so this problem is a little bit unusual because it already kind of tells you from the beginning which one is the more desirable option. So we already know that buying is better. We want to know kind of how much better it is. Okay. But with that said, you can actually still use, even if you didn't know that buying was the better option in this case, you'll see that when we do the rate of return analysis, that if it wasn't, you would get a negative interest rate. So you can see by the way that we set this up, we're going to end up with a positive interest rate, which is telling us that this is better. Okay. Okay. And so we want to find another way to kind of phrase this this question here is to find out the interest rate where these two options are equivalent. Okay. And then if you end up with a positive number, that means that buying is the better option. Okay. Okay. So the way to do this is we're going to set up a present worth equation for both options and set them equal to each other. All right. So first we have the present worth of the leasing option. Okay. So the present worth of the leasing option, we have a minus 2,500. That you can consider to be our initial cost. So that's the leasing cost for the first month. Okay. And then we have the $2,500 monthly leasing cost for the next 23 months. Right. So this is P 20 minus 2,500 P over A. I and 23 months. Okay. We can set up the same expression for purchasing. Okay. So for the purchasing option, we have a minus 40,000. Extra zero there. Okay. That is our upfront cost for buying. And then we have the salvage value at the end. So that's a plus 6,000 P over F I in the 24th month. Okay. All right. And so if we set these equal to each other, we can simplify it a little bit. And then we're going to solve for basically the interest rate for basically using the same methods that we did before. All right, so if we set these equal to each other, we have minus 2,500, minus 2,500, E over A, I 23 is equal to minus 40,000 plus 6,000 P over F I 24. Okay, so let's put everything into one side of the equal sign. So I'm going to move everything to the right. So I'm going to move this term added over here. The minus 2,500 I'm going to add to both sides. And so if we do that, we get 0 is equal to minus 37,500 plus 6,000 P over F I 24 plus 2,500 P over A I 20. All right, and so now that we have this expression here, you can use your chosen method to find out what the interest rate is in this case. Okay, I'm going to show you how to do it with the table method, but of course you can plug in the formulas and plot it. Okay. Okay, so using the table method, let's test out different interest rates. So let's first try I is equal to 3%. Okay. So basically, whenever you see I here, you're going to plug in the conversion factor for 3%. So you're going to go to the compound interest table for 3%, find these conversion factors and plug it in. Okay. All right. So for this one, we get minus 37,500 plus 6,000. Okay. We look up the conversion factor for P over F, and N is equal to 24. And so for 3%, this is 0.4919. Then we have a plus 2,500. Then we have the P over A factor for 23 months. And so that is a 16.444. Okay. So all I did there was look up the conversion factors for an interest rate of 3%, just plug it in. Okay. So if we punch this into a calculator, what we get is 61.94. Okay. So it's not 0, right? So we want to find the place where this whole expression is equal to 0, but it's a starting point. All right, so let's try 4%. Okay, so let's try this this problem here with 4%. We have minus 37,500 plus 6,000. Since we have a different interest rate here, we're going to have a different conversion factor. So for I is equal to 4%, this first conversion factor is 3901 plus 2,500, 14.857. Okay. All right, so you can see our conversion factors went down a little bit. So if we punch this into a calculator, we get 1983 and 10 cents. We're getting a little bit warmer, and so we're getting closer to 0, but we're not quite there yet. So let's try the next interest rate, which is 5%. Okay, so for an interest rate of 5%, we're just going to use the same expression here. The only thing that's going to change is just the conversion factors. Okay. Okay. And so our two conversion factors in this case is 0.3101, and our second one is 13.489. And so we plug those into a calculator, we get minus 1916 and 90 cents. Okay. All right, so we cross zero, and so we can see that our present worth equation here has changed sign. So that tells us that our rate of return is somewhere between 4% and 5%. Okay. Because we know that the present worth crosses zero in that sense, and so to find the true rate of return, we're going to have to use interpolation. Okay. So the rate of return, I'll say I is equal to. Now you write out the formula again. So we have I low plus I high minus I low. Okay. Multiplied by 0 minus PW low divided by PW high minus PW low. Okay. So just a simple linear interpolation formula. Okay, so remember, the tricky thing about this formula is that PW low here corresponds to the present worth associated with the lower interest rate. Okay, so the lower interest rate in this case is 4%, and the present worth that's associated with it is the 1983 and 10 cents. Okay, so just be careful. So that's kind of the trickiest thing about this formula. So remember, in this case, I low is 4%. I high here is 5%. Because we're interpolating in between those two. PW low in this case is the 1983 and 10 cents. Okay. PW high in this case is the minus 1916, 90 cents. Oops. So let's plug in all those things, and you can kind of see that we're when we're at 4%, we're at plus 1980. When we're at 5%, we're at minus 1960. So it should be pretty close to right in between the middle of those two, maybe slightly leaning towards 5%. Okay. So when we punch this in, we get 4.51%. All right, and so what this basically is telling us is that if we choose to buy this piece of equipment, we're going to save money. We end up with a positive, interest rate here. Okay, basically we would get a monthly rate of return of 4.51% if we purchase this machine over the 24-month period. All right, question. So since there is 4.5% on the interest table, is it worth it to use that value instead of the interpolation? Yeah. So in this case, I did it using interpolation just to kind of illustrate to you, but we actually do have a compound interest table for 4.5%. So if you did actually use the 4.5% compound interest table, you would probably get, pretty close to zero in this case. Yeah. Mm-hmm. So does getting close to zero but not exact dictate a good answer? It depends on how close to zero you are, because depending on the problem, you may be $5 away from zero. $5 may be pretty insignificant. In this case, it would be pretty insignificant. So I would say it's pretty close to zero. But for another problem, $5 may be a lot. And so I think it's kind of hard to tell how close you are to zero. without at least doing a few different options. So even if you're going to use the compound interest table for 4.5%, I would at least check 4% and 5% to kind of see how close you are in those cases. So in either way, you're going to be doing multiple tables. And so, you might as well just kind of check all your boxes and look around the area to see how close you are. Mm-hmm. All right. Any questions on this example here? Okay. So before we move on to the next example is the $100 versus $200 option. Okay. I want to kind of look back and kind of how we actually set this problem. Okay. And so in this problem, we were comparing two different options. We were comparing either the buying option or the leasing option, right? And the way we kind of set this up is that in order to find the rate of return, in order to find the interest rate, we basically set these two options as equivalent. Okay, that's essentially what we did here. Okay. We took both options, we computed their present worths, we set them equivalent to each other, and we found the interest rate. And that interest rate was our rate of return for our problem. Okay. Eventually, what we did was that after we did that, we did a little bit of algebra. We ended up with this expression here, right? So this expression that I just circled is the one that we actually use to do our rate of return. Okay. There's another way that you can get this expression here. It's nothing magical. It's just kind of another way to interpret it. Okay. So let me come back up to this table here. Okay. Let me make a third column here. Okay. So this third column, it's not another option, but it's one way that you can kind of interpret it. And so in this column here, let me take the difference in between the buying column and the leasing column. We're basically just going to subtract across the row here. Okay. Although they're kind of flipped. And so you're going to you have to kind of put the buying option and kind of put it up front there and subtract the leasing option. So, hindsight 2020, I should have put the buying option. Okay. All right. So for the first line right there, we have a minus 40,000 minus a negative 2,500. So that is going to be a minus 37,500. Okay. For the next row here, we have a 0 minus a negative 2,500. So that is a positive 2,500. Okay. And note that second row there represents months 1 through 23. So this here is a series. Okay. And then finally, we have the last row, which is a 6,000 minus 0. And so that is a positive 6,000. And we know this is a one-time cash flow in month 2024. So this is a future sum. Okay. All right. And so if we take this column here and we find its present worth, and so if we write out the expression for this present worth, we get present worth is equal to minus 37,500. Okay. That's already an initial a present sum because it's the initial cost. Okay. Plus 2,500. We know this is a uniform series, and so we need to do P over A, I, and 23. Okay. Let me clear out some room here. Plus 6,000. Since this is a future sum, we have P over F I and 24. Okay. That should look very familiar to you because that is exactly the expression that we have here that we use to compute our rate of return. Okay. So another way to kind of get this expression, whenever you're comparing two options, right? When you're comparing two options using rate of return, you're basically setting both of them, you're setting up an equivalency equation and you're finding the interest rate from that equivalency equation. Okay. Another way to do this is to actually just take the difference in between these two. Okay. And then find the present worth of them. And this kind of methodology right here is kind of the basis for how we do comparisons with rate of return. So this technique of taking two different options, taking the difference between their cash flows, computing their present sums, this is known as incremental rate of return analysis. Okay. And so when you're comparing two options using rate of return, okay, the way to do this is to find the rate of return of the difference between the two options. Okay. All right, and so you're going to be taking the difference between the two options. Oftentimes, these two different options are going to have very different costs and very different benefits. Okay. Typically, what you do, because then the question now arises of how do you take the difference, right? So because it matters which option goes first, because that's going to tell, right? So typically, what you do is you're going to put the option with the higher initial cost first in the difference equation. Okay. And so the difference equation is going to set up like this. So we're going to have the higher cost option minus the lower cost. And note that the only thing you really consider here is just the initial cost. Okay. And we do this, I mean, part of the reason we do this is just to set a convention, right? A lot of things that we do in engineering, there's sometimes not like a very logical or practical reason why we do things, but we have to do things consistent. And so the convention is set and we just kind of follow that convention always. So this you could kind of interpret this as something like that. Okay. But it does kind of set us up pretty well because when you do this, right, what your present worth equation of this expression Okay, and so if you do this and you do it strictly based off the initial costs, that means when you take the difference between them, that difference is always going to have a negative present value. Right, just because that's just how we set it up, right? So we set it up so that whatever your higher initial cost is, we're going to put that one first in the expression. Okay. So this is usually how a lot of how a lot of companies usually kind of think, is that they think of things in terms of initial costs and how that initial cost is going to pay off in the end, right? And so this kind of gives our expression here kind of like almost make it seem like an investment. Okay. Or for investments, typically what you do is you have a high initial cost, so you pay money out front, and then over time you gain some benefits to kind of make up for that initial investment. Okay, and so by setting up this way where you have the higher initial cost option first in the difference, it's almost always going to look like an investment. Okay. Okay. And so once you do that, you can find the rate of return of this option. So we're going to compute the rate of return of this difference expression here. Okay. So after you compute this, this will give you something called the incremental rate of return. Because it's not the rate of return of each option individually, it's the rate of return of their difference. So that's why we call it the incremental rate of return. Okay. This is then often compared with something called the minimum attractive rate of return. And since that is a mouthful, we often shorten that to MARR. And actually, incremental rate of return, we often shorten that to IRR as well. Okay. So you're going to compute the IRR and compare it to the MARR. Okay. Okay. And then depending on this comparison, depending on the relative values of these two numbers, it's going to tell you where you should kind of spend your money. Okay. All right. And so if the IRR is greater than the MARR, by the way, the MARR is usually something that's given to you in the problem. Okay. Usually that's some kind of investment goal that the company often sets to you. So they said, here's your project. We want to make sure we get a rate of return of this. Okay. So the MARR is given to you. The IRR is what you compute. Okay. So if the IRR is greater than the MARR, this tells you that it's better to invest in the higher cost option. Okay. But if the IRR is less than the MARR, In that situation, you're going to go with the lower cost option. Because the idea behind this is that if your incremental rate of return is high, so if it's greater than the MARR, it's better to invest all of your money into that higher cost option because that's going to give you the best yield for your entire budget, right? But if your incremental rate of return is less than your MARR, that basically tells you that you're not going to get as much bang for your buck. And so if you keep investing in this option, in the more expensive one, it's not going to give you as big of a return. So you should take your money and kind of spend it elsewhere. That's what this is saying. Okay. All right, so it's a lot of vocabulary, it's a lot of concepts, but I think once we kind of finish up this example here, it'll become pretty clear. Okay. Any questions on this though before we jump into that example? Okay. All right, so let's finish up our example that we started on Tuesday. Okay. So this option here, this example here, it's we're comparing our two investments. Okay. So option A is we're going to invest $100, and so we have a $100 cost. Okay. And if we invest that $100, we get $150 back. Okay. Option B is we invest $200, so that's a $200 cost. And then what we get back from this is $280. Okay. And so for this problem, if we know that the minimum attractive rate of return, okay, so this is what the company sets to you, said that for this $200, we want to get a minimum rate of return of 10%. You want to determine which is the better option. Okay. I guess I should mention too that this return is not instantaneous. This is a 1 year rate. It's not like a spot machine. You enter the money, you get it back right. So it's you invest it and you have to wait. You have to wait a bit. Okay. So let's start by computing the individual rates of return. So in this case, I kind of chose the numbers for this to be pretty straightforward. Okay. All right, so for the option A, right, we only have a 1 year period, so we actually don't even need the compound interest table for this case. Okay. And so we can basically say that our interest rate here is basically our return on investment. So we put in $100, we get 150 back. That means our return is $50. Okay. Divided by 100. Okay. So that nets us a 50% rate of return. Option B here, our return is $80. So we're going to have $80 like that, divided by 200. So we have a 40% rate of return here. Okay. So if you just look at the individual rates of return, you would think that, option A is the better one here, because that gives you a higher rate of return, right? Remember what we talked about last time. So the fact that you're even considering these two options has already told you that you have a $200 budget. Right? Okay. Otherwise, you wouldn't even consider option B. Option B would not be an option if you didn't have a $200 budget. Okay. And so if you look at it from the perspective of, what's the best use of that $200, right? And so if you go with option A, right? You're not going to spend the whole $200. You're going to put $100 in, and then from that $100, you get $150 back. You add that to the original 100, you get a total of $250, right? Whereas for option B, you invest the entire $200 and you get that $280 back, right? And so which option gives you the higher amount of money is option B, actually. Okay. Right? Because you're going to get a higher overall return from that. Okay. So I chose this example just because it's you can actually do this problem without even doing rate of return. But let's see how we actually set this up as a rate of return problem, an incremental rate of return problem. Okay. So let's take the difference here. So let's take our difference of the higher cost option minus the lower cost option. Okay. And so our higher cost option in this case is the $200 investment. Okay. We have a minus $200 minus a negative $100. Okay. So that our expression still has a negative present value at the end. Okay, so that's good. And then our returns here. Okay. Our return for the higher cost option is 280 minus the return for the lower cost option, which is 150. Okay. And these are in the future. Okay. And so if we perform these out and we compute its present worth, okay, the present worth of the difference in this case is going to be minus 100. Okay. That's going to come from the present sum plus 130 P over F, I, and 1. All right. So in this case, we only have one time period, so we can actually solve this pretty easily with the formulas. We don't even need to go through the tables here. Okay, so our P over F formula we know is 1 over 1 plus I. Okay. And that 1 plus I is raised to the first power because our n is only 1 in this case. Okay. And so since we only have an exponent of 1, we can solve for I. Okay. And so we solve for I in this case, we get 0.3, which is a 30% rate of return. And since this IRR, if we go back to the problem statement, right, we know that our minimum attractive rate of return in this case is 10%. So since IRR is greater than MARR, since IRR is greater than the MARR, it's better to go with the more expensive option in this case, which is the $200. Okay, and that confirms our kind of back of the envelope calculations for this kind of simple case. Okay. Okay. Any questions on this? All right. So what is that MARR? Because it kind of seems like I kind of just pulled that number just out of my ass. And for this equation, we kind of did, right? So let's talk a little bit about what the MARR represents. And when a company gives this to you, where are they getting this number, right? Okay. The MARR usually is some kind of expression of a market interest rate. So if the company were to take that money and invest it in like a bank, some kind of bank account, that is the return that they would get. Usually it's stocks actually, so it's more stocks than banks. Okay. So of course that market interest rate is it's a function of just how the economy is currently doing at the moment. So right now, interest rates are pretty high, so MARR is going to be pretty high as well. As you can imagine, that's going to influence, the types of decisions that companies make. Because if they can take that money and they can invest in stocks and make more money that way, they'd rather do that than pay you, right? So that's usually what you're competing, right? So if we redo this example, right? And so instead of an MARR of 10%, let's say that the market's doing super good right now. And so let's say that the MARR is 40%, right? So the company can take your $100 or $200 and invest in the market and get a 40% return. Okay. All right. So from our problem, we found that the IRR was 30%. Okay. Since 30% is less than the 40%, okay, we know from our table that it's in this case, it will be better for the company to invest in the lower cost option. Right, and so the lower cost option in this case would be the $100 option. And so they would take $100 of that $200 budget, invest in option A, right, get their $50 back, and then they take the rest of that $100 and invest it in the market. Okay. Okay. And so let's kind of visually look and see what that looks like. And so you have your budget of $200, and so you invest $100 of this into option A. In that case, you get $50 back, and so you end up with $150. Okay. Then the $100 that's remaining, they can take that and invest it in the market at 40%. Okay. Right, a 40% rate of return in 1 year will net you $140. Okay. And so if you add these two together, what you get is a total investment of $290. Okay. And so if you compare that to option B would be to spend $200 to get $80 back, right? This would give you a better return on your investment. Okay. So that's usually what the MARR represents, and it usually represents some kind of market interest rate that the company would get if they invested outside. Okay. All All right, so hopefully that gives a little bit more context in terms of, why we do the incremental rate of return and why we're comparing it to this MARR. All right, any questions on this? Okay, all right, I got one more example for you today. It presents kind of a little bit of a complicated situation, or more complex than our other examples so far. Okay. So all of the examples that we've done so far, we've basically we're basically working under the assumption that every option or every investment option has the same time period, right? We know that from present worth analysis, that if we're comparing options with different product lives, we have to kind of adjust what we do. We have to use the least common multiple. That applies here as well. So in this example here, let's say that we have two machines that are being considered for purchase. Okay. So let me write these out. And so we'll call these machine A and machine B. Okay, so both machines have their initial cost. Based on the outputs of the machine, that we can estimate what the revenue is going to be. Okay. Okay. Both machines have a salvage value that can be applied once the machine reaches their end of life. And what's different about this problem is that both machines will have different useful lives as well. Okay. All right, so for machine A, let's say that its initial cost is $200. So that is a minus because that is a cost. Okay. The revenue that machine A is going to produce is $95, okay, per month. And we'll say that we can salvage machine A for $50. Okay. Right, but machine A only has a useful life of 6 years. Okay. Okay. So for machine B has an initial cost of $700. Its revenue per month is be $120. And the salvage value is $150. And we'll say that machine B lasts for 12 months. Okay. We have different product lives in this case. Okay, so let's also look at the difference between the two. Okay. So the more expensive option in this case is machine B. So we're going to take machine B. We're going to subtract machine A. Okay. And so we take a difference of their initial cost, we get a minus 500. Their difference between their revenue is 25. The difference between their salvage value is 100. Okay. For their useful life, we're going to do what we usually do in present worth analysis. We're going to do this based on the least common multiple. So the least common multiple in this case is 12 months. Okay. All right, and so if our MARR in this case, let's say our MARR is 2.5%. Let's choose which option to go with. All right, so this is a pretty standard incremental rate of return problem, and so we've done a lot of the setup already, but we have that additional wrinkle of machine A only lasting half as long, okay? So that means in order to reach 12 months, we have to buy a replacement for machine A at 6 months. All right, so that's going to throw an additional wrinkle into our equation. All right, any questions on just the setup of the problem? Okay, all right, so let's go ahead and set this up. Okay. All right, so first thing we're going to do before we even talk about the replacement, let's set up our present worth equation just based on the difference. Okay. We have present worth is equal to, we have a minus 500. That's the difference in their initial cost. We have a difference of $25 in revenue. And remember, revenue is a monthly benefit. Okay, so it's going to be 500 plus 25, P over A, I, and 12. Okay. Plus $100. Okay, this is the difference in the salvage value. So this is P over F, I, and 12. Okay. All right, but that's not the full expression. We also have to account for the replacement costs. And so at month 6, okay, and so at month 6, we're going to buy our replacement for machine A, and we're also going to salvage the original one. So the first machine A that we purchased, we're going to salvage that one and buy a new one. So that means in year 6, we're going to have a minus 200, or month 6, excuse me, minus 200, and a plus 50. Okay. All right, but of course, we're doing this in present worth analysis, and so we're going to take both of these costs, both of these, I guess both of these transactions, both of these cash flows occur in year 6, month 6, excuse me. They occur in time period 6, and so we need to convert these to the present day. We have these to convert to present day. Okay. So we're in luck here. So both of these conversion factors are the same. So we can kind of simplify and bring this both together. And so together, they give us a minus 150 P over F, I, and 6. Okay. Okay. So that right there is going to be an additional cost for machine A in month 6. So let's take that and let's add that to our table up here, okay? So I'm just going to add a new row. We're going to add a new row here for replacement costs. You don't have to add the new row. I'm only just doing this just for illustration purposes. Okay. Okay. So machine A is going to have an additional replacement cost of 150 in month 6. Machine B doesn't have that because machine B is already designed to last for 12 months. Okay. All right, so this last part's the kicker here. And so, you know, when we take the difference, remember we're taking the difference of machine B versus machine A. So if we take the difference between that last row, we have 0 minus a negative 150. And so that's going to end up being a positive 150 in month 6. Okay. Okay, so let's go ahead and add that to our present worth expression here. Okay. So our present worth expression of the difference is going to be our minus 500 plus 25 P over A I12 plus 100 P over F I12 plus 150 P over F I6. So we have an additional expression here, or additional term here for our present worth based on that replacement cost. Okay. All right, so that's so that looks good. So let's go ahead and compute the rate of return of this entire expression here. Okay, so let's start with 1%. All right, so our present worth in this case is going to be a minus 500 plus 25. For I is equal to 1%, that P over F or P over A factor for 12 months is 11.255 plus 100 P over F I12 at 0.887 plus 150 times 0.942. Okay. So 3 conversion factors to look up in the table. Okay. If we punch this into a calculator, what we get is around 11. It's $11 and some odd cents, but it's close enough to 11. Okay. Let's look at the next. Compound interest table, which is we're going to skip to 1.5%. Okay. Okay, so our present worth in this case is going to be minus 500 plus 25. This first conversion factor here is 10.908 plus 100, 0.836 plus 'okay. We plug all that in and that gets you about minus $6. Okay. It's like $6 and some odd cents, but it's close to it. Okay. So from this, from these two results here, you can see that the incremental rate of return is somewhere between 1% and 1.5%. Okay. It's probably going to be closer to 1.5%, just because the minus 6 is closer to 0. So it's probably going to be around maybe 1.35%. Okay. So you can interpret at this point, you can interpolate, you can find the exact rate of return. Okay. But you actually don't need to go further in this, because if you remember from the beginning of the problem. The MARR in this case is 2.5%. Okay. And so no matter what, no matter if you're in between 1.1% and 1.5%, it's going to be less than the MARR. Okay. And so in this case, there's really no need to go through the trouble of interpolating. We know what the answer is going to be. Okay? And so since the IRR is going to be less than an MARR, the better option is to go with machine A. All right. Any questions on this? Okay, all right, so that's all I got time for today. So we're just about out of time. So on Tuesday, when we come back, we're gonna go over, I call them kind of other analysis techniques. They're kind of just miscellaneous techniques, before we kind of move on to the next big thing, which is taxes. And so we have kind of a break week next week, before we kind of move on to kind of something pretty heavy. And so again, on Tuesday, I'll have more information about the midterm exam for you. So the midterm exam, remember, is not next Tuesday, but the Tuesday after that. So next week, I know we'll probably spend most of the time kind of preparing for the exam and talk about that. Okay. All right, so thank you guys for coming today. I hope you guys have a good rest of your day. Hope you guys have a good weekend, and I will see you on Tuesday. What's up?
I have a quick question. It's not related to the class, but it's related to counseling.
Mhm.
I missed foods. I didn't have the option to put foods in thermal lab this semester, right? And it's typically a prereq for the power, like whatever it's next spring.
Yeah.
But I was wondering if there's any possible, because I simply don't want to do my graduation to spring of 26. Is there a way to take those two concurrently?
So we do offer 476A and 476A, or 476A and B over summer. And so if you missed out on 306B this semester, you would take it next spring 25, and then you would graduate summer 25.
Summer, but see, then I'm also, I'll schedule a counseling thing with you.
Yeah.
I think that's the best option, because I did also miss a couple other things that would be fall.
Gotcha.
25,
Okay.
I think.
Okay. Yeah, let's go ahead and make an appointment. Are you in senior design? You're gonna be in senior design next.
Yeah,
next year. Okay. I think we should be able to move. Usually we could move some stuff around. I highly doubt it would be a spring 26 graduate, but maybe either a summer 25 or fall 25.
I'm really hoping fall 25 is like my goal.
Okay. That's probably,
Or summer 25, that also works really.
Yeah.
well.
Let's go ahead and make an appointment. We'll talk about it. Usually we can move some stuff.
Do I just online?
Yes, yeah, so there's a link. Did you get the email I sent?
I did not get it.
Okay, why don't you send me an email to my personal one, my just ran at Fullerton, and then I'll send you the link to make that one.
Okay, thank you. I'll get you that email later.
Okay, sounds good.
Thank you. Have a good day, sir.
You too.
Just reminding you, I know it's a few weeks ago, I have a conference next week, so I'm not gonna do it.
Okay, yeah.
I know you don't take attendance, so that shouldn't be an issue.
Yeah, so just catch up on the fact that I think that probably the most relevant thing for you is that on Tuesday, I'm gonna talk about just kind of the format for the midterm. And I'm gonna post a study guide next week. So just kind of watch the lecture when you get a chance.
I'm so glad you posted this. It saved my life.
Yeah, it honestly saves me work too, because then students have to miss and watch the lecture. So.
Your office,
Exactly.
you like, it's on YouTube.
Exactly.
Was on.
Speaking of, we did post the homework and it's not ready to get back.
Yeah.
So can I have an extension on that? Is that what-
So for that one, it's a bit tough, but it is right up by the midterm. So because I like to post a solution before the midterm, so I can give you, I can give you another day, Saturday. And I'll post a solution for Saturday.
That way everyone can study.
Yeah.
Okay, that
It's gonna be on Tuesday, so it's pretty quick. So I wanna make sure everyone gets the solution.
Yeah, because I get back from doing that day, I'm not going like straight to work after I get back.
Okay, yeah, I'll give you until Saturday to.
Okay, cool, thank you.
Gotta stop juicing, man.
I'm not juicing.
Have a good one, see
You
you.
too.
Oh, I won't see you next week, actually.
Well, see you the week after that.
Yeah, have a good one.
Okay.
I skipped class yesterday, or not yesterday, a couple days ago.
Yeah.
I was studying for an exam.
Uh-huh.
I don't know exactly what I missed.
Yeah, so just watch the recording. So I think I put it on YouTube, but I haven't posted on campus yet. But it'll be up today. So yeah, just watch the lecture.
Okay,
Yeah.
perfect. Thank you.
Yeah. What's up?
So it's a freebie. I'll see you later. Once the water takes that in. Huh? Once the water takes that.
Usually for this one, it's the gradient here is usually. The P1, 5,000. P2 is the $2,000. P2 is your, okay, and then you convert that again. Yeah, this new here. From 9 to 7, right? And yeah, and then convert that to is not from 0. Per year. I've like a couple of times, I don't know, like. Let me double check with my own solution. Can you screenshot this and send it to me on email?
Is it the one that has 8 million as an answer?
No, the one after that.
That one, I'm not exactly getting the right number.
Yeah, there's always gonna be, if it's like within rounding, I think it's within a couple percent, then it's usually fine. Cause I use the tables, and I think like when I did this one, I have a different, I think the decimals on the tables can be a little bit different compared. Depending on which version that you use, so. So there's always gonna be a little bit of rounding, especially because I use MATLAB to do all my calculations, but using calculators is gonna be a little different.
Correct, yeah.
That looks like it's something might be different, but I'd have to take a careful look at that. But if it's like $1 or $2 off, that's. Thank you. Yeah.
I was actually gonna wonder, for that one, actually, the one that has 8 million as the answer. Something really weird happens, well. It was right here, right? It was F over A, right? I'm finding F. I'm kind of it's getting me confused on what, like the final sum and the present sum. I know present sum is supposed to be like. I'm looking ahead of time. This is how much money I need to set aside to pay for that entire thing, right?
Right, yeah.
And then final sum is, all right, I'm gonna salvage, this is gonna be salvaged for $6,000. That $6,000 is actually gonna be this much, right? That's F, right?
Yes, so think of it in terms of the time, so when these cash flows are occurring, so in this one, the LA City Council, they're gonna pay it off all at the very end, right? So this is money that they're not gonna pay this money until the very end, so you can almost think of it like a debt.
Oh, and the lump sum at the end, at 8 years.
Exactly,
But I always thought that was present sum, because I'm like, that sounds like you're just you're setting aside all the money. So you can afford it in the future, so you can pay for it, so
Yeah.
shouldn't that be P?
so you're right, and so in one sense, you could think of it in terms of like, you're saving that money now. But in this case, like the arrangement that they have with the contractors, that they're not gonna pay it off until the very end, so.
Oh,
So
they're paying it off at that time.
Exactly, so they could set aside the money right now and then just kind of invest that and save it until the end. But probably what's more likely, and the reason they have that arrangement, is that they're gonna collect that money over the years through taxes and whatnot, and just pay one just big, huge bill.
So when it comes to present sum, it kind of assumes that money that you're holding aside goes through interest, right?
Yes, yeah, so think of it in terms of time, so I think that's the easiest way to think about it. When is this money gonna get paid out? And so since this money's not gonna get paid out to the very end, that's what makes it a future sum. But if another way that these projects are usually funded is that, the city would pay a huge sum up front. So they give the contractor a huge sum of money. It would be less than that, because it would be a present sum. So, let's say they give the contractor, $6 million. That would be something they do up front, right? That's when they would pay it out today versus paying it out. So I would think about it in terms of time more so
Gotcha.
than the interest rate.
All right, that makes sense. Huh, and when it comes to gradings, right? It goes from, it starts at year 0. Year 1 actually has no G,
Mhm.
and then year 2 is when the G starts.
Exactly, yeah,
But you still include that first year,
they
right?
do, yeah.
Oh, okay,
So that first year is like 0 G.
gotcha. Awesome, thank you.
Yeah, no problem.
Man, if only you taught thermo and fluids.
I used to teach fluids. I haven't taught in a while. I actually I miss fluids a lot.
Oh my god, please do.
I'll
Seriously.
see. I'll ask. I always ask, but then, they usually put me elsewhere.
Yeah.
All right, have a good day.
Professor, thank you.